Okay, now the binary search is going to address one of the facts that if we have a big array, then if the number that we're looking for is the last one, it's going to take some time before we can reach it. So there's a better way that is going to try to do it faster, try to find it faster, and this is called binary search. I mean, this one, we've seen it a bit before. Remember when we were using this hidden number? We're trying to find the hidden number between 0 and 100. We were searching for that number, and what I told you is the faster way is to try to always cut the space into two halves. If I'm looking for a number between 0 and 100, the first question I would ask, is it 50? And then if it's smaller or larger, then I'm going to find out what it is. However, this works only with one condition. What is the condition? Is that the array, for the binary search, for it to work, it has to be sorted. Now, if you sort your array and then you use the binary search, it's going to work. If your array is not sorted, it's not going to work. So the binary search requires that your array, your values, they have to be sorted in any direction, smaller to largest or largest to smallest, it doesn't matter, but it has to be sorted. Now in this case we're assuming it is sorted from the smallest to the largest, and then this is how it works. Let's say I'm going to look for the number, let's say 81. Now 81 is here, I find it, I know it is there. Or maybe like any other one, maybe another one, the 898, something like in this place over here. Now notice, if I need to use this, I need to check and repeat this 30 times, asking questions before I can find it. But if I use the binary search, I'm going to slow the speed a little bit, so I'd like to talk about it. And then this is how it works. So the binary search, what it does, it just takes the size of the whole array, because this is what we're starting with, and then it's just calculates which one, this is the minimum, this is the maximum indices, and try to find the middle. The middle is what? This plus this divided by 2. So 31 divided by 2, 15.5. We don't care about the 0.5 because there's no index to be having a 0.5. So I'm just going to assume that 15 is my middle. And this is what I'm doing. I'm just getting the low. The low is, the first time, the low is going to be 0. The maximum, the high, is going to be the highest index of the array. And then I'm just going to get the middle of that by just adding them differently, divided by 2. This gives me 15. Now this 15 now, this is what I'm doing. I'm going to check, is this the value that I'm looking for? And you have here some kind of explanation of what is going to happen. I'm going to step forward just to see. Now the question is this at this position, this value, is it equal to the value that I'm looking for? No, it's not. Now the next step I need to know, is it in this side or in this side? I can know that because now the numbers are going to be sorted. So if this is bigger than this value, that means it's going to be on the right side. If it's smaller, it's going to be on the left side. And this is what I'm going to do here. Now what if, now after I find that this is not equal, I'm going to check, is it smaller, this value here, is it smaller than the value that I'm looking for? In this case, yes. Now notice what will happen now. The minimum should not stay here, the minimum should be, well, after the middle. I know that this is not the value that I'm looking for, so it should be here, not here, because what would be the point? I know that this is not the where the number is going to be. This 15, we've seen it, it's not our value that we're looking for. So we will start checking like here. That's why it says now the low is going to be mid plus 1. So this mid is 15, we're going to add 1, and then now our next step is that I'm going to repeat the same thing by checking now for the value in this half of the array. the upper half. So after asking just one question, I was able now to remove half of the array. The second question is going to remove another half of the half. So I'm going to do the same thing again. Now the next step is that this is my low, this is my high, didn't change. Now what is going to be the middle? Just calculate this plus this divided by 2 is going to give me the middle, and I'm going to ask, is this in the middle equals to the one I'm looking for? No, it's not. And then I'm going to just check now the next question. Is this smaller or bigger? So know which one is going to move. Now this is smaller. Actually, in this case, it's going to be always smaller. But we'll try another step where it's going to be something else. So now again, we're going to keep moving the low, and every time now calculate the middle, and then keep moving the low until we're going to be finding it. And then we found it. It gives us the position. Now let's try again. How can I again just play? Okay, now let's try again with another number. It's going to be something here, let's say 671. 671. And let's start. And then so we start with the full array, and then we calculate the middle, and then we compare. Is it equal? No. So we look which part of it is going to be. Now we calculate again the middle. Now you see it's going to be, let me pause here. Now we're just comparing this, and we found out that this is not equal. Then we need to find out which part of the array it should be in. Now is this bigger than this or smaller than this? So if this is smaller, so we're going to move the low. But now this case, this is not smaller, which means the next step we're going to move the high to be this mid minus 1. Because we know it's not the mid, so it's mid minus 1. And then we're going to split this into half and find out what is going to be the next position. And then we keep doing the same thing. Now is it equal? No. And then now we found that this is our low, and that's the middle. And then the middle is not equal. Let's find out which position is going to be. So this number is bigger than that number, which means we need to move this one down. And this is what is going to happen. So now we move it down. It happens now to be the low and the high are all at the same place. Which means if you calculate the middle of this, 20 plus 20 divided by 2, plus 20 divided by 2, so that's 20. It's going to give you the same number. So this is going to, all of them are going to be in the same place. But what is going to be interesting for us is that because we're going to ask about the middle, if it's going to be equal to the value, and this is what it is. It's going to be equal. And that's how it works.
So for that one, only the middle can find the value.
Yes, we compare always to the middle. Now the thing is, what happens if it doesn't exist? Does it exist? No, it doesn't. So now what happens if it doesn't exist? I'm going just to speed up a little bit so you can just see what is going to happen. So it just keeps repeating until, well, we decrease again the size of my array that I'm looking at, and then it keeps looking until, well, there's no much left. And then once there are no more, well, it's just going to say, okay, element was not found. How it does that? Because I'm going to keep repeating until this low exceeds the high. Because every time if it's smaller, I'm going to move it right. If it's higher, I'm going to move it left. And then if at one point the high becomes smaller than the low, then there's a, I finished everything. I couldn't find it. And that's what this is all about. This is the binary search. Now, if this seems to be kind of, well, maybe it's not a big deal. I'm doing a lot of search anyways. But let's have a look at when you use a large number. Now, if I'm looking for a large number here in in a linear search. So I'm just going to go one by one by one by one. Look at how many times I'm repeating and until I find it. And then because now exceeded, because this is sorted. So if it's sorted, it's going to take less time. But if it was unsorted, I will have to go through all these and find out it doesn't exist. Now with the binary search, look how fast it finds it, that it's there or not there. So it just can I start again? Play. So it takes less time for the linear search. It keeps repeating so many times until it finds it, and even though now it's stopped because it's sorted, but if it wasn't, it will take much more. So that's the advantage of this binary search, is that it is going to close in on the value much faster. However, there is a prerequisite for this to work. The array has to be sorted. If it's not sorted, it's not going to work. So how do we implement this? Yes.
Can you just explain? You said sorted and not sorted.
Now these numbers that you can see inside the array, they're starting from the smallest to the largest. That's what I mean with the sorted. Like for example, if I'm looking for a value 444, this is the linear search. Goes from the first. I mean, first of all, it doesn't exist, right? As you can see, it's between these two. It doesn't exist. So it keeps moving, try to find out, and then it doesn't find it. It doesn't find it. Why did it stop here?
Because it's bigger than
Because this is bigger than this. I don't need to keep going because it's sorted. Now, what if it was not sorted? It will have to go until the end and not find it. But with the binary search, it just takes less step to know that it's not there. So that's going to just, okay, it was not there. As opposed to how many times I'm just checked it. So that's the difference. Now how to implement that? Well, basically we have this is the algorithm, but I'm just going to try to do something about that. So let's just now we're going to keep this, but instead of calling the linear search, we're going to be using the the binary search. So the binary search requires that the array should be sorted. So I'm not going to do the same thing here, but I don't have a binary search. I just would like to make sure that I have these to be sorted. So what I'm going to do is, I don't know, but maybe what I can do, maybe something, I'm going to start with 1 just to have something also random, and this is going to be copy and paste. Why 1? Because the 0 I'm going to put it myself to be a random number between, let's say, 10, 1 and 10, and then from that I'm just going to do something like this. So what does this do is that randomly I'm going to select a number between 1 and 10, and then this puts an array of 0. Then from 1 and onwards I'm going to take the array of 0 and I'm going to add to it a random number between 0 and 9, and then I'm going to always do that, a random number between 0 and that, between not this one, I'm going to make it not only 0 but the one before, the I minus 1. So the first time I is going to be 1, 1 minus 1 is going to be 0. The next time I'm going to take the previous value, the one before it, and then this is going to give me a random hold on, there's an error because I don't have this method here. I'm just going to make it -1 and then I'll put it later. Let's run again. So I just would like to see that these are the values, and you can see these are sorted, but if they are not equal, they are going to be up. If I don't want to have two that are equal, just going to maybe add 1 to it. Now by doing this, I'm just don't need to. So as you can see now, the values are going to always go up, always go up. Again, values always going up. All right. So it is sorted, right? Always. Because what I'm doing, basically, this is going to be this value here between array of 0 between 1 and 10. But that's kind of interesting that I get 12. Am I missing something? It's kind of nice. Every time I run, I have, okay, this is 7, which makes sense, but what before I had something kind of weird. This is 14. How can I get 14 here? Array of 0, it's a random number between 0 and 9, and then I make it between 1 and 10. And how comes I got 14? It's kind of interesting. Oh, because I'm not displaying array of 0. You see, I'm not displaying it. That's why I was. And now, because I'm displaying array of I, which is I is going to be 1. That's why I got something kind of weird. Now it makes more sense. Now every time the first one is going to be between 1 and 10. All right. So now that I have my array that is going to be sorted, let's write the code to find a binary search. So the binary search is going to be something like this, with these to be the number that I'm going to get, and I am going just to create this method, create the method binary search, and this is just going to do this. I don't want to do that, and then I need to do the same idea. I'm going to do the same thing. The position is going to be the first one that I'm going to return it after I finish trying to find it. Now I need a couple of things. Now I need to remember which is the low and the high. What is my minimum, which is going to be 0 the first time, and my maximum, what is going to be array dot length. Is it though? Just array? No, you cannot do that. This is an array inside of a variable. Array.length is not right, because array.length is the, let's say if you have 32 elements, it's going to give me 32. But if I have 32 elements, the index, the last index should be 31. So array.length minus 1 is my last index. So this first index, or maybe this is called low as it was called, and then this one the high, so we can use the same terminology. The low is 0 because the minimum, the lowest index is going to be 0, but the highest is not going to be the array.length, but array.length minus 1. Now I need to have a while loop, because as long as I'm going to repeat, as long as the low is smaller or equal to the high, I'm going to keep repeating. If it doesn't, if the low now exceeds the high, I just need to stop. And then when I stop, I'm just going to return position. Either it's going to be minus 1 or something. Now, the first thing that I have to do is that I need to declare the mid. Now, my mid, I need to calculate the mid, which is going to be low plus high divided by 2. Now, this is int by int, so which means even if it's point something, I'm going to discard the point something and just remove it. I don't care about it. And then what should happen now? Now that I have the mid, I should ask a question. If what? If the mid is equal to the position. Yeah, because it's kind of the position is the position that I get, so it's the number that I would like to have. Okay. if it is equal to the number, the mid. What is the mid? The mid is the index of the position, and I'm comparing an index with a number. It's the array of the mid that I'm like to compare. And let's just remove this just so I can use the same terminology. I'm going to call it the key because we use the same name here, and here instead of the array I'm going to call it list, so we use the same terminology so we don't get confused. In the list I'm going to take the mid and compare it with the key. If it's equal, then the position that I'm looking for is the mid. Same thing that happened here. If it's equal, that's what I'm looking for, because this is the position that I'm looking for. Here is, instead of the I, it's the mid that I'm looking for, because I found it's equal to the key. But what if it's not equal? Now this is where I'm just going to compare. Compare what to what?
Mid greater than high.
Mid, is it greater than?
Mid greater than high.
Mid greater than high? No, I'm doing.
Than high.
If array at mid is greater than the number or
I'm looking at the number itself. If array dot mid is array mid, I don't have array, it's called list now. If the list of the mid is smaller than the key that I'm looking for, that means now this value that I'm looking for, let me just maybe go back to here and let's start again. No, stop. Okay, binary search. Now if the first thing that I'm doing is that, hold on, if I'm looking for this number, if this number now is smaller than this number, that means which one should move? If this one is smaller than this one, this is the question. If this is smaller than the number that I'm looking for, which one should I move? No, not the high. This low should be now here, because this is smaller than this one, which means now this value should be on the right side here, not on the left side.
Mid plus one.
So if on the right side, which means this low here should be moved to mid plus 1. So if this is going to be the case, so low is going to be the mid plus 1. Else, that means it's going to be, if this is not smaller, that means this one, I mean in this case, well it's not the case, but maybe afterwards. If I move now this one, probably it's going to be, oh still, that's not a good example, but let's say if I have, which one? Let's say 304. And I'm going to start again from the beginning. Next, now I'm comparing. If this one is smaller, that's not the case. If this one is bigger, that means I'm going to be in the else here, because it's the number here is not smaller than this number, which means then what needs to happen is that this high should be moved to mid minus 1. So the high is going to be mid minus 1. And then after doing this, I need to do again, calculate the new mid based on this new thing. Next, I need to calculate a new mid. Now, after I have these two, I need to calculate the new mid, which is, this is what happened, and then keep doing again until I find it, or the mid, the low and high are not becoming the same order. I think we're ready to try it. Let's see. Now this is our array. What number you'd like to find? 32? This means this is an infinite loop. And we know, in order for us to see it, I'm just going to display low plus space high, or maybe mid, and then high, and this way we're going to be able to see what is going to happen. And let's try again, and let's look for 37. Okay, clearly there's something that doesn't move. So the first thing that happened is, let's just go up. We had the size is 14. So the high is 13, which makes sense. The low is 0. The middle is going to be 6, because 13 divided by 2, that's 6.5. It's 6. And then, after we did that, now let's find out. Hold on. I just want to fix this. Now, after we did this, now what should happen is that we should be here. When we are here, is array of 6. This is 0, 1, 2, 3, 4, 5, 6. Oh, it happened to be the number that we're looking for. So if we put the position to the mid, and then we go back up, did we change low? Did we change high? Nothing changes. So low plus high, that's exactly again the same thing. And then we repeat.
We have a break, we find position.
We should stop. Once we find that we found the position, we should not keep going, because this condition will always be true. We should break. As soon as we find that the position is the mid, we should stop from repeating. Now let's try again, and this time with this 32, and the number is found at position 6, because it was the middle, so it immediately was the middle. Now let's try with another number which is not in the middle, so we don't have this one shot. Let's say 70. Now this is how it starts, and the low is 8, because actually we skipped the first one, which would be nice if we can see all of these. So every time after we calculate the mid, we just display everything. And let's run it again. If we type with 78, oops, not here, 78. So it sees it goes from this to be from 0 to 16, and then the 8 is in the middle, and then it finds out that the 8, I don't know where it is, somewhere here. So it's the one that we're looking for is not on this side, so it just now move the low to be, instead of the 8 to be the 9, so the one here, so 0, 1, 2, 3, 4, 5, 6, 7, 8, so 9 is going to be here. So I'm looking now from here to here, and then it's just going to be the middle to be 12. This is 16, 14, 13, 12 is 71, right? So this is our mid. So it's from here to here, and this is our mid, and this is not going to be equal. So now it's going to keep going further. So from here to here. Is that 13, or I get lost? This is 16, 14, 15, 14, and it's starting from here, from 13 actually. So the middle is 14, and then basically that was it, and it just finds it. So this gives us, like, it's looking for one at a time, half of the array at a time, as compared to this one which looks at one at a time. So these are the two type of search algorithms that we're looking at, and that would like you to just practice these. So let me just free you so you can do that.